Good morning. Morning. I obviously think I'm in America, and I'm not. I'm just outside Swindon. So it's most definitely good afternoon and a sunny afternoon here in the UK for a change. Welcome to everybody. We would love to be doing this session to you in our offices so you can really get the hands-on with the equipment and right there at it. But this is the next best thing. You can see live demos and hear from our experts in the comfort of your office or with the COVID restrictions probably at home. So thank you all for joining in this session. And we're not going to spend the whole time on this session going through reams and reams of PowerPoint. What we've done is a nice balanced couple of hours where we do a mix of PowerPoint where we explain what we're going to do, what we're going to show you, and then the main part of the session is around the actual demos and showing what we have is real and how it can be appropriate to you. And with that as part of the objectives, we would really encourage you and welcome you to interrupt at the flow at any time, ask questions. You can either ask questions in the question box on the webinar screen, or also there's an option to raise your hand. You'll see a little icon on the bottom right with a little yellow hand, I think it is. Yeah, not this hand, a yellow one. You'll see a little yellow hand, and that will tell our moderator to unmute you, and you can ask the question directly. And we really welcome that. I mean, if this were live when we were in front of you, you would do exactly that. So please feel free to interrupt the flow and make this. The more intimate we make this, the more engagement you get, the better experience you will have. So before we move on to the session, I think it beholds us to just give you a very brief introduction of who Ribbon are. I think you probably know this, but just in case. You may know us as ECI, which we were up until about almost exactly 12 months ago. And then we merged and formed a joint company with Ribbon Communications. And at that point, we really became a proper global company. In the past, we were very strong in EMEA and APAC as ECI, not so strong in North America. With the Ribbon Communications people were very, very strong in North America and strong in Oceania, and not so strong in some of the regional variants in Europe and Africa. So now we're present in over 140 countries, and we have a combined annual revenue of just shy of $1 billion and about 4,000 employees. What this really means, this sort of size of company now, is we're able to take on board with confidence any project that you have, no matter what the size of that project, because we have probably done projects of that size in the past. Whether that be the 70,000 nodes we've got for mobile backhaul in India with our IP optical portfolio, or supporting all of the voice stuff that is required for Teams. Our SBC voice breakout is the voice breakout for Teams, and we're present in all of the major tier ones and financial institutions with our voice solution from the Ribbon legacy products. So absolutely key that we now have that breadth to be able to handle any project you like, and this shows you that customer base. You can probably see the logo for most tier ones in the world listed there, and then most of the major critical infrastructure providers as well. I mean, most Deutsche Bahn was added, where we got an extremely successful project and continually ongoing winning new business with Deutsche Bahn and working in partnership with them, moving that solution forward. So I think Marco will touch on that a little bit later. So next slide, Marco. Okay, so just a recap of what ECI brought to this joint company was a converged IP optical portfolio, and over the last 12-18 months we really invested heavily in moving that portfolio forwards. We now have a full IP transport stack, so that's all of the IP MPLS type functionality that you might want in IT applications, plus all of the deterministic IP transport you're going to require in your OT applications, which we were already unbelievably strong in. We've now strengthened that with support for things like RSVP, TE, and then a little bit longer term for you guys, things like segment routing, TE, etc. And of course, the ability to support 5G, which again becomes important for you guys if you look to become new telcos, but also as you're looking to backhaul all of the IoT and IED devices you've got in there to help your infrastructure become smart. At the same time, we haven't left our optical portfolio behind. That has, again, had considerable investment to make sure that you've got state-of-the-art capacities and density and moving along with the SDN type functionality. Again, Marco will touch on that more. And as we move on to the next slide. And from the cloud and edge portfolio, we have a full set of voice solutions ranging from session border controllers, call controllers, media gateways, application servers, through to the analytics and security of the voice applications, identity assurance, robocalling, etc. So really, really a full set, and we have those deployed, as I said, in most of the tier 1 service providers around the globe, but also in really major mission critical, business critical applications in the enterprise, financial institutions, etc., governments, defense, or the full range. So a real good mix of stuff there. So I will now hand you over to Marco, who was obviously getting impatient to get onto his stuff. I'll hand over to Marco, and he will talk to you about what we're really doing today. Thank you, Marco. Oh, before I go,
David.
Just remember, you can feel free to ask questions as we go along.
Okay. Thank you, David. And for a few minutes, I will share my camera with you, but as soon as I get into the main presentation, I will turn off my camera so you can see the content of the presentation more clearly, because I'm too beautiful for your eyes to adapt. So what we are going to see today, we are going to see a very short theoretical and presentation about the key trends in the critical infrastructure market. You'll see also some trends in what are the key technology enablers in the critical infrastructure market as well. And then has a kind of demonstration how real the things that I will mention in the first session look like in the field. We will have a very short demo that will describe what the transport layer for the critical infrastructure network should look like in the eyes of the management and the provisioning and operational. And then I will come back with some dedicated and focused use cases focusing on two market segments: the electricity, the power utilities, and the rail utilities. So we will look into some sectorial trends inside those specific verticals, but focus on the applications and what we have done in some customers in the field. After that, we will follow on a continuation of the demo that we can see through the management what we are capable of doing in terms of provisioning, encryption, and other nice features that we believe are very essential for the critical infrastructure market. And then we will have a very short demonstration of what is our Light Insight, our report generation engine looks like, and what are the benefits that you will be able to have from this platform. And of course, a Q&A session where we will try to address all the questions that you may have during this presentation and beyond that. So with that, I will go into the major presentation. So I will briefly turn off my camera and let's focus on the presentation. So we'll talk about the new generation utility, what are an overview of the utility communication networks and emerging requirements. So when we talk about telecommunications in the critical infrastructure market, basically it's the lifeline of the utility sector, because it's through this lifeline that all the mission critical services, all the high performance connectivity between data centers and servers and etc. all the security assets, from the access to the core, everything should run and should be connected to this very important pipeline. So this is a backbone for the utility operations. And when we talk about utilities and look into where we started many years ago and where we are aiming to be, the changes are quite large scale and quite dramatic. So the changes are in the infrastructure, leading to much more fiber in the network, broadband systems and circuit requirements, the migration from TDM, SDH, and SONET to new technologies, and we'll talk about the new technologies that are on the table today, IP and optical technologies, the real-time asset monitoring requirements that are leading the industry to modernize their networks to increase capacity all over the place. And we must take into account certain changes that are very critical to the electricity, transportation, oil gas industries, all the critical infrastructure scenario. And those changes are driving the network to increase capacity anyway. So this is beyond pure migration from old technologies to new ones. It's an expansion of the current OT network capacities much beyond what we have today. And one of the key drivers is the digitalization and the surge in data traffic that is increasing a lot in the last years, and it tends to increase in the next years as well. So let's take a look at it where we started. And when we started, the utility 1.0, it was basically relying on three major pillars. One of the pillars was called resilience, because it should be a very protected network, should recover its services on very short times. It should have a very high level of availability and support of the critical low latency and low jitter services, ensuring that the end-to-end values for the latency and jitter are maintained throughout the operation of the network. And on that, SDH and SONET and TDM have provided quite an excellent performance and is still providing that. But the utility has, we know, is evolving. So we are now talking about the utility 2.0. We are looking at more distributed assets connecting to the grid. We are talking about renewable sources, solar farms, wind farms, etc. We are looking at the migration in the service level, in the application levels from legacy technologies to Ethernet and to IP, and those new services are increasingly need for more bandwidth. We're looking at provisioning of a secure separation from IT and OT, because despite the fact that those networks were clearly and quite strictly segmented in the past, the number of interfaces between IT and OT is increasing day by day. Okay, so in some operators, in some critical infrastructure operators, they are talking about really a convergence between IT and OT and security, and the strict separation between the services must be achieved even though it's running on a similar platform. Cybersecurity is highly on the table today, has the latest market surveys show more than 78% of the critical infrastructure entities all around the world is being targeted by very sophisticated cyber attacks. And in that matter, new technologies like virtualization and edge computing are entering into this world. So the utility 2.0 is adding new pillars to what is needed to evolve and to operate properly. We have to add scalability, so the capacity to grow the network to reach more sites with the same capacity, to have advanced levels of operational compatibility. So the IT and OT traffic can connect between themselves smoothly, and but without compromising the strict performance requirements that we have in the previous utility 1.0 model, and increased levels of security. physical security as well as cybersecurity security. And in this evolution, we see many phases and many layers. So in one point, the OT network that was highly reliable on circuit-based technologies, 80%, even more in some other cases, is migrating to a situation where most of the services will run over a packet infrastructure, while a very small number that they will, I believe, that will maintain for the years to come, we will still utilize circuit-based technologies to be for the connectivity. In the service layer, we are looking at an increased increment of IP Ethernet-based services and applications. We are adding the existence of the local area network as essential for the connectivity of those elements. In the substation level, for example, we are migrating from electromechanical connectivity to a LAN-based connectivity, Ethernet. It's also been driven by the IEC 61850 standards. And we are looking at the introduction of TDM and SDH services, both native and using circuit emulation technology. In the transport layer, as we talked before, where it was solely based on SONET, SDH, and TDM, we are now looking into a mixed environment where the dominant technologies will be new generation optical packet technologies like MPLS, OTM, WDM, and a certain quantity of SONET, SDH, and TDM will remain in the system. And last but not least, in the medium, we see an increased quantity of fiber optic being installed all over the place. And this is something that is happening not only in the generation side or in the transmission side of the utilities, but also in the access, okay, in what we call the field area network. So we will see more and more fiber and a combination of microwave and fiber that will be the dominant technologies in terms of medium. And here is the place to talk about 5G. 5G will be a major game changing in this process. So when we talked in the previous slides about data, this slide shows you what volume of data we are talking about. And this is a very brief and glimpsey into three very typical service applications that runs in a critical infrastructure network, for example, electricity network. For example, we have the phasers, the PMU's connectivity. So every PMU phaser emitter unit that provides the measurement of angle magnitude of the three different phases or two different phases in the electrical grid, they are delivering an amount of 15 gigabytes of data per day. So this is an average per meter. So and the number of PMUs being introduced in any power grid is increasing almost daily and weekly. The other thing that contributes a lot for the huge quantity of data are the smart meters. If we take into account the scenario of 1 million subscribers with smart meters, the amount of data those subscribers will produce per day is about 1 terabyte of data per day. And if we add surveillance cameras that are being increasingly installed all over the place to monitor the security, to control access, but also to monitor and supervise some gauges and some performance and some operational issues in the substations and railway stations and all over the place, each camera is delivering per day 9 gigabytes of data at least. So all in all, a typical data center in a critical infrastructure entity in the operational network would have to deal with from 6 up to 8 terabytes of data per day. And this is huge and should be backed up. It should be backed up in different locations, of course. And this is just a glimpse of what are the amounts of data the new network is having to deal with. So this is not only a matter of obsolescence or end of life of SDH and TDM, but an expansion of the network in almost all parameters. And let's remember that an OT network is not an IT network. So the major values of an OT network are clearly signed here in this slide. We are talking about reliability. We are talking about sensitiveness to latency and jitter, and security. So those are the three pillars that are the most important building blocks for any OT network. And only looking at one of the most critical applications today, let's, for example, differential teleprotection, we are talking about a latency of 5 milliseconds or less for fault clearing end-to-end. We're talking about 0.5 milliseconds of asymmetry required in this teleprotection circuit, and 50 milliseconds with minimal and sometimes non-packet losses for fast healing. So those are very tough requirements, and the new network will have to provide to assure those values when it comes to the real time. Another important topic that we should consider is that critical infrastructure definition is being quietly rewritten since the start of the COVID-19 crisis. And those are good news, meaning that those pillars, those values that we just spoke before, will be increasingly important in other sectors of the economy. So, for example, when we're talking about public health, we will look into resilience, security, scalability, protection, attention for low latency applications, etc., has an important value for those networks serving the public health sector. The same for municipalities. Before some years ago, a smart city project was considered quite an extension of an IT project. Today, the smart city projects are more and more considered like a mission critical project in all parameters. So the level of resilience, availability, and protection required by the network increases likewise. And let's not forget telecommunications. I believe that most of the societies, the modern societies today, they cannot imagine how their life would be without telecommunications. So telecommunications is in several countries being defined and being considered as a fourth utility with the same criteria that we have talked before. So the level of availability and resilience and the robustness of those networks tend to increase as we speak. So let's talk about the technologies that we have available on the table today when we try to modernize our OT network. And in the demo that you see very soon, the differences between the technologies will be clearly shown by RAM, and you will be able to see it live, the major differences. So the most important technologies available today are MPLS-TP and IP-MPLS. And the IP-MPLS, of course, not the original flavor of IP-MPLS, but IP-MPLS implementing the full traffic engineering stack with the RSPTE, which is essential to ensure the levels of availability, latency, and protection required for mission-critical networks. Each of the two technologies have a set of advantages and key features, and because of that, in Ribbon, we have selected both of them to be part of our go-to-market in the critical infrastructure segment. So basically, in Ribbon portfolio, we will be capable of deploying both technologies simultaneously. While in let's say purely technical and professional terms, we still recommend MPLS-TP has the best technology to replace SONET SDH. Okay. So this is something that is not said only by Ribbon. It's been stated back from 2017 by SIGRE. SIGRE is an association including more than 1,200 power utilities all around the globe. And in their Green Book publications from 2017 till today, they are endorsing MPLS-TP as the technology of choice to replace SDH because it provides SDH-like behavior, and you will be able to see in the demo. But also has the field-proven capacity to meet all the latency and jitter constraints that are critical for teleprotection services and other new coming systems in the critical infrastructure market. But we are not only based on that statement. Also, NERC-CIP in the United States has recommended through their different standards from CIP 002 to CIP 009 the utilization of non-routable protocols like, for example, MPLS-TP as a choice that increases the security level of the networks compared to a routable protocol like IP-MPLS that, as we all know, utilizes several IP protocols, BGP, OSPF, RSVPT, and others. So this clear difference between the layer 2.5 MPLS-TP and the layer 2, layer 3 IP-MPLS also has an impact in the security level of the critical infrastructure network. With MPLS-TP, we have other benefits, okay? And we are not blind and only focusing on MPLS-TP. As I stated before, we can provide full IP response to any customer requirement, including MPLS-TP and IP-MPLS, with IP-MPLS, with RSVPT, or without RSVPT. And one of the things that is increasingly being required on these networks is timing and synchronization. Okay, if we look into the increased number of PMUs being installed all over the electrical grids, 1588 version 2, the telecom profile, the new telecom profile, which is a bit more powerful than the utility profile, is being widely deployed all over the places. So we are looking at a transport like OAM, we are looking at a transport like operation that you'll be able to see, and the transport like resilience. And one of the beautiful advantages or features of the MPLS-TP is that regardless of the network topology, meshed, ring, etc., it still, if properly configured, can maintain and deliver the sub 50 milliseconds protection switching and the short and ensured end-to-end latency and jitter values. So with that, yes, I'm on time. We will go to the demo part, the first part of the demo that will guide you through. And after that, I will get back to you. Thank you.
Thank you,
Ram,
Alko.
in your hands.
Thank you. Thank you. Thank you. Please tell me when you see my screen.
We see your screen. Thanks, Ram.
Good, good. Thank you. Okay. So first of all, hi, everyone. My name is Ram. I'm the group manager in Ribbon, responsible for all proof of concepts related to our packet transport devices. And today we're going to have a demo on our management system, the Lightsoft. The main goal for this demonstration is first to show you our capabilities of management, FCAPs, how easy it is also to provision all the different services related to critical infrastructure. I will show you also our capabilities in regards to the different rates we can support on the same platform. If it's from 64K channels up to 200 gig links. And also I'm going to show you how we can manage in the same management system and also on the same devices and even on the same ports, both the MPLS-TP and IP-MPLS technologies. So I hope after this demonstration you will see how powerful this Lightsoft management system and the possibilities that you can do with our devices by supporting all the different rates related to critical infrastructure and both MPLS-TP and IP MPLS on the same platform. So let's start. So this is our Lightsoft, and this is the main view of the Lightsoft. You can see, of course, the different network elements. Each box here, each circle here represents a different device, a different NPT in this example. You can also have what we call groups. So, for example, if you have many network elements on your screen and you want to divide them by regions or other things that you can think about, you can, of course, group them together, and it's very, very convenient for your working process and also for the monitoring. Another thing that you can put here is we can add a background map if you want to locate your devices in geographical order. So we have the option also to add a map in the background. In my case, this is a lab, so I just have a boring gray screen in the background. So this is let's start from the topology options. So this is the different topology options that I talked about it just now. For example, to create topology links, the topology links just represent the physical connection between the different network elements. As I said, we can have groupings, and we can have also different other features. I will not go over everything because the Lightsoft has huge amount of possibilities. I will just mention, the most important ones, the ones that probably will be the most interesting for you. Another thing that we have here is what we call insert and remove. This is very nice feature in case, for example, you're increasing your network and adding more network elements, and there would be cases that you would put the network element inside an already existing link. So we have the option with the NMS to do what we call insert any, and the NMS will actually take care of everything that on top of this link, like tunnels, services, and everything, and create the different configurations related to the services and tunnels on the new network element. And of course, this is a huge time saver on such operations. Okay, so this is a small overview about the topology options that we have. Of course, as any FCAP systems, we have full fault management support. If it's by seeing alarms, threshold crossing alarms, event, we have event logs, we have security events related to things that happens on the Lightsoft. We can track all the configuration, all the operation that is done on the Lightsoft. Of course, this is important for security reasons. We have alarm forwarder that we can forward alarms either if it's to SMS or to email addresses. And of course, it works with different filters in order not to send everything. And just for the example, I will open the current alarms window, and you will see how it looks like. Okay, so for this example, I'm seeing all the alarms on all the network elements that I have in this NMS system. You can see that I have the different device name, the object name, the probable cause, when it happened. I can do filtering, I can do sorting, I can do acknowledgement, I can add comments. So you have full control and monitor about your network health. And usually when I'm going to customers and you have these big screens in the NOC, this is one of the windows that is always opened in the screen, always the current alarm window, and then immediately when something happened in the network, you immediately see it pop up in the list, and it's very easy to view it. And of course, everything is also represented on the actual devices and links. Okay, for example, here you can see that this group is red because it includes some alarms. Okay, if I will select this group and do current alarms, it will filter only the alarms related to the network elements resides in this group. Okay, so every object in the NMS is colored according to the actual current alarms that resides on it. For example, if this link, I will do some fiber cut or something like that, you immediately see this link is turning red. Okay, so this is another view that usually we put on the screens in the NOC to see the the overall health of your network, and it's very easy to see if something pop-ups because you see immediately some red color on the screen. something very important because before I'm going over all the other options that we have, this Lightsoft can handle many technologies in the same network system. What do I mean? It can handle SDH and SONET. It can handle a packet, if it's MPLS-TP, IP MPLS, and everything related to that. And it can also handle our Apollo devices. These are the DWDM, OTN products. So for example, if you have a mixed network that is built from both optical and packet devices, you don't need different management systems. You don't need to mess with different learning curves for different systems. Everything you can do from the same system. And something very nice that make it even easier is what we call the layers. Okay, so the NMS provides us some kind of filtering according to the specific technology. So for example, if I'm working on the physical side, this means the actual physical connection. So we have a layer that represents this physical connection. If I want to work only on things related to Ethernet MPLS or IP, I can go to the specific layer, and immediately you will see the view is changing, and I can see here only objects that has the specific technology, in this case Ethernet MPLS. And when I will show you tunnels and services, I will talk a little bit more about this layer in more detail, because this is the layer that's important for us. But just for the demonstration, if for example someone wants to work on an SDH network, on an optical network, you just need to click and immediately it filters out all the relevant objects that relates to the specific technology. So this layering make managing different technologies in the same NMS very, very easy. And of course, managing all the stuff in the same NMS, and we can do also end-to-end provisioning over NPTs and optical stuff at the same time. Saves a lot of time, and of course, it's very, very simple. So this is just about the layering that we have in the NMS. Okay, let's continue. Some things before we start the actual things related to traffic. We have the system tab that we have here all the configurations, of course, related to security. Okay, I have full control for all the users, the groups, the operations that can do. We can, define users that has read-only, write to specific objects. This is what we call the VPN. That means that I can create different groups of objects. And for example, if you have, I don't know, let's say North region and South region, and you want only the engineers that are responsible for South to see only the South, and only the engineers to see the North, objects. So we can do a specific configuration, and it is called resource domains. Okay, and the default one, of course, is all. And I can select all up to the granularity of a single port and assign this port to a specific resource domain. And the user that will use this resource domain will see only this port. Okay, so this is a very nice feature that can help you from security point of view and also from operational point of view to create your own resource domains and let the engineers only see, and of course provision or other stuff only on the relevant objects that they need to deal with by day to day. Okay, so this is a very powerful feature as well. And we also have support for LDAP and radius, of course, for radius for authentication, and LDAP if you want to connect to your organization LDAP and take the users from there. We have the Trails tab. I'm not going to talk about it because this is pure SDH and SONET Trails. This is legacy. Of course, this NMS can also handle these legacy devices. We still have legacy devices that support SDH and SONET, pure SDH and SONET, not over a packet. So you have the ability to do it from here, but I will not go into details here because it's less important. Before we go to the tunnels and services that are the most important ones, any questions? Okay, good. So this is the tunnels. The tunnels here relates to MPLS TP tunnels. Okay, I will talk later on about IP MPLS, and I will show you how it handled in the NMS as well. but just for the comparison, IP MPLS, you don't need to create tunnels, okay, because IP MPLS is working according to dynamic protocols, and except, you know, traffic engineering tunnels in IP MPLS that you need to do some provisioning, but it's not the same as MPLS-TP, and you do it very not exactly the same, but it will be similar. But when I'm talking about tunnels here, I'm talking about MPLS-TP tunnels, and I want to show you what are the possibilities here and how simple it is to create a tunnel. And you will see it's very, very, very similar to how we did in the past provisioning for SDH. It's even more simpler than SDH. So let's go over it and see what we have. First, of course, we have the different options. If it's creating new tunnel, opening a tunnel list and see all the tunnels that I have in my system. Tunnel consistency is a very nice feature. It helps us to synchronize between what we have in the management system and what we actually is configured on the devices. For example, if by mistake someone deleted something, changed something from the actual device, you will see a flag here that indicates that there is some tunnel that is not the same in the NMS database when comparing it to the actual network. And it's very easy to straighten things out with this feature. You just do 2 or 3 clicks, and then you're synchronizing again between your network and between your NMS. We have here what we call automatons. Okay, this helps us with the provisioning phase. For example, if I have a network of, I don't know, 10 network elements and I want to have full mesh of tunnels between all of them, I don't need to do it by one. If you're calculating the amount of tunnels you need to do only for 10 network elements, it's huge amount. Okay, so we have the tunnel automatons that we can use them. I'm going to select what are the network elements that I want to participate in the full mesh, and with just 2 clicks I can create multiple tunnels at once. Okay, we have the same for what we call root and leaf. These are later on where we'll see services. We have services that's called point to multi-point. That is mean that you have a root and the traffic is going from the root or to the leaves only. So we have an automaton also for this kind of architecture. Let's go to the actual provisioning and you will see how simple it is. First thing, just for simplicity, I will go to the Ethernet MPLS there. Just a second. And I want to explain about this layer a little bit. Okay. Okay. So this is the Ethernet MPLS. You can see here that it's a little bit different from the view that you saw on the physical layer. And I want to explain what exactly is the difference. So you can see here different icons. Okay. This icon represents the technology, the Ethernet MPLS technology that resides on this specific network element, the element that was named 162, if you remember. And this one for the element that is named 161. Okay, what are those? Those are what we call IP MPLS networks. Okay, these are created automatically. When and also we can create them also manually. This is a representative of the connectivity between the network elements. Okay, this is a virtual connectivity because you can think that, let's say, for example, I have some DWDM network as the underlying layer. For this layer, it's not important. I don't need to know about all the different objects that resides on the connectivity. I just need to know if I have connectivity from network element to network element. Okay, because only the network elements that has the capabilities of packet need to know about that, and I need to create on them what we call tunnel cross connect, or what we call a VSI. It's a virtual switching instance. This is an instance of a service. So these are virtual connections, and underline it, there could be, I don't know, 30 network elements that run DWDM or something like that, just for the example. So these are the logical, the virtual connectivities between the network elements. I created 2 of them with 2 different links that they are running. By the way, they are running on top of MaxSec, but I will show it to you later on. And now let's open the create tunnel window again. Oh, sorry, I was in filter mode. Everything you do here in the NMS, if you click on something, it's doing filtering. It's very, very convenient. just by the way, because it happened. So this is the window of the create tunnel. Of course, basic stuff like name and customer and things like that. I want to focus on the important stuff. So first, we can create what we call a protected linear tunnel. What does it mean? This is a tunnel that has two paths. If I want to correlate it to SDH, it's very similar to SNCP. You have a main path and you have a protection path. And of course, this protection is sub 50. Okay? And the advantage of this case here is that I can also run what BFD protocol on top of it. So if we go back to the example I used, that you have an underlying layer of DWDM, and if you have a cut inside in the middle of the DWDM network, the endpoints of the packet side will never know that it's, you have a failure. Okay, but by running BFD on top of the MPLS TP tunnel, I can identify very, very quickly any failure that I have in the network. So these tunnels also support BFD. Okay, so for this example, I will create a protected linear tunnel, and let's see how it goes, how simple it is. First, I want to say from where to where I want the tunnel. So I will click on this endpoint and on this endpoint, and that is it. I want the tunnel from here to here. One more parameter that I want to say is the specific classes of service that I want to support on this MPLS TP tunnel. And later on in the demo, when I will show you the difference of quality of service between the IP MPLS and TP and how we can handle it very, very well in the NMS, and how we can differentiate between the class of service between TP and IP from OT to IT, you will understand exactly what I mean here. But for now, just see how simple it is in order to create it. So just for the example, I want this tunnel only to carry class of service 0. So I'm selecting a committed interface rate, let's say 10 megs. I can also use access rate if I need, but for example, let's just use 10 megabytes for CIR, and that is it. This is the only thing I need to do in order to create the tunnel. Okay, then I can click on what we call a complete tunnel. The complete tunnel will calculate how the tunnel will look like, will show you the paths, and this is just, you know, like a double check before you're creating the tunnel to see that this is really what you wanted to do. Okay, then just clicking the activate, and this will actually download the tunnel cost connect to the devices. And this is how simple it is to create an MPLS TP tunnel. Very, very similar to what you know from SDH, even simpler. And another thing that you will be able to do from the NMS is what we call explicit path selection. Okay, we have the option to say the NMS, if we want to go over a specific path, I can do what we call explicit path include. That means I want to tell the NMS I want to go through this path. Okay, and I have what we call the explicit path exclude, where I want to tell the NMS go everywhere besides this specific object that I selected. So this is another thing you can relate to that as traffic engineering. So we have the path include and path exclude. One more thing I want to say is regarding the pathfinder of the NMS, how it works. Okay, so we can decide, if you go to the system preferences, you can see that I can select the optimization criterion. Okay, this is for the NMS pathfinder. By default, it's minimum hops. It will select the shortest path. I can tell him, but use minimum metric or minimum length of fibers in kilometers. So I can play with these constraints, and the pathfinder will consider it accordingly. One more thing it can consider is SRLG, ducts. Okay, in most cases, fibers are not a single fiber that go in the ground. It's going inside ducts. So I can say to the NMS to also to relate to the SRLGs. And this is very important, for example, for protection, because the NMS will know not to create the protection path on the same duct, unless there is no other option, of course, but it will let you know, it will give you a warning that the protection is not optimal. So this is another important feature that the Pathfinder of the NMS also supports. So this was a brief about MPLS TP tunnels. Any questions before we go to services? Great. So before we start with the services, I want to show you, I talked about at the beginning that the NPT can support rates from 64K, all the different protocols you're familiar with from critical infrastructure, teleprotection, V11, V35, CODIR, ENM, FXS, FXO, everything you can think about, we can do that at the same platform that resides with the 100 gig rates. It's funny, but the same box can support from the minimum rate of 64K up to 100 gig and even 200 gig. So I just want to show you the shelf view and how it looks like and the different cards and different options before we go to the service provisioning, to the actual provisioning. We'll just open the shelf view. Okay. So this is an example of NPT, one of the NPT families. This is an example of the NPT 1050. And this is actually the NPT, the bottom part. Okay. The top part is what we call an extension shelf. Okay, and this extension shelf is very important because in this extension shelf, I can put any of the different PCM modules in order to support the different protocols that you need. I just put for an example like V35, teleprotection. If I open it here and do slot assignment, you can see the full list of all the modules that I can put in the extension shelf. Okay, we support all these different protocols, and all these protocols are not going to go over pure PDH and SDH. It will go over packet, and this is the nice thing here, that you can pass these old legacy protocols that are still in use, and you can use the evaluation of the networks if it's TP or IP, and transfer all these legacy protocols over packet networks, and I will show you it in just a minute. Okay, so and the additional advantage of using extension shelves that first, it doesn't occupy any slots in the actual NPT if you need it for data ports or other stuff, or for example for what we call for SES. Okay, this is an example of a SES card that supports 32 E1s. Okay, so we can also transfer E1s and STM1s and STM4s over a packet with SES services. And another advantage of the extension shelf, and in the future, if you are going to remove this protocol for some reason because, I don't know, certain devices move to work with Ethernet, so you just take out the extension shelf and you don't need to do a lot of reconfiguration or reassignment of things on the NPT. Okay, and of course the extension shelf adds you more slots that can be used. You can have in each extension shelf 3 what we call EM10 cards that have all the different modules in. So 3 of them, and each one has 3. So it's 9 different modules that you can put in every extension shelf. By the way, this is the MACsec card that we are going to talk about later on. It's called DHC4sec. It supports 4 ports. It could be 10 gig or 1 gig of encrypted with MACsec. Okay, let's go back to the NMS. Okay, so let's open. First of all, I'm just going to do a brief overview. In the NMS, as we support both MPLS TP and IP MPLS, so you will have both Layer 3 VPN and Layer 3 VPN and Layer 2 VPN, both on the same network management system. We have lists, we have consistency checks. As I explained for the tunnels, it also exists for services. And of course, it's duplicated both for Layer 3 VPN and for Layer 2 VPN. So let's see the options that we have in Layer 2 VPN. First of all, we have different types of services that we can create. Okay, we have the traditional Ethernet MPLS ones that can go over MPLS-TP or IP MPLS if it's point-to-point, multi-point to point, point-to-multipoint, and we have the different SES services. If it's SES PCM, this is for the lower rates, like teleprotection, and SES MPLS, this is for the higher rates like E1s and STM1s. Okay, so we have a lot of different types of services that we can do from the NMS. For the example, I will use some SES PCM just to show you how simple it is, because this is the more complicated service, but you will see it's not complicated. Okay, data services are very, very, very simple. So I intentionally want to use the PCM service because it has a little bit more configuration you need to do. But I will also show you an example of data service that you will see the difference. Okay. So this is a SES PCM, and very similar to MPLS-TP tunnels, you need to select the endpoint. Okay, so for tunnel, we select the whole PE, the provider edge, because we need the tunnel to go to the PE. But for services, we need to select the specific port. So instead of one click, it will be 2 clicks. So you click select endpoint and you get a tree. The tree is represented of all the slots and cards that you have in the specific network element. Okay. Then you just need to drill down to the specific port you want to select. Let's do a service of teleprotection, for example. I will select it. You have the option to select which time slot you want to use from it. Okay. And it comes with this small matrix, and you can just select if you want one T slot or you want all the 12. Okay, very, very simple. And then I do close. I'm going to do the same thing on the other side. Click the time slot. Oh, I didn't do selection there, sorry. Okay, and this is it. This is how I selected the endpoints for my service. PCM label is because we can have multiple channels on the same E1, so we want to differentiate between them, and this is how we do it with the specific label. The second phase is now we want this specific 64K channels to go on a specific E1, okay? Because what we carry in the SES payload is E1. So again, it's very, very simple. You do right-click, select the SES endpoint, okay? And in this case, we are going to select an E1. And again, each E1, in this case, it's a framed E1, 31 channels. By the way, this is called SES over PSN because it has the ability to select the different time slots. SATOP is a full SES that carry all the E1 as one structure. Okay. Again, I want on the E1 side that it will go on the time slot number 1, and also for the other, I want it to go on slot number 1. Okay. And from selection of endpoints, that is it. Okay. This is the service. This is the only thing I need to do. Okay. The dotted line here, you see here, it's mentioning that I selected in this case to use IP MPLS network. Okay. And we will talk about it later on. We'll talk about IP MPLS, but because you saw it, I will just explain what it is and how simple it is to move to MPLS-TP. One checkbox. That is it. Okay, I wanted to use MPLS-TP tunnels, or I don't want it to use MPLS-TP tunnels. This is the only things I need to do when I'm creating a service and I want to decide if I want to use TP or IP. Very, very simple. For our use case, I'm going to use MPLS-TP tunnels. One more thing you can do, it's not mandatory, is to configure different configurations related to the E1, like the timing, for example, or the layer 2 payload. And besides that, just do complete, and that is it. Complete and activate. In this case, also another nice feature is telling me that it didn't find any MPLS TP tunnel that is connecting between these two network elements. So it's asking me if the NMS wants to create it for me. Okay. So this is another option, or you can create in advance your tunnels and the NMS will select them automatically. Okay, so complete, activate, and this is how we create a PCM service. Let's see an example of a data service. If you will need, let's say, for example, a point-to-point. So it's exactly the same. Select endpoint. Okay, just doesn't matter. I will not say this. Go into more than that. Select two endpoints. Okay, again, this is IP, and that is it. And for data, we have different parameters like VLANs or a class of service and polycells that you can fill out the parameters here. And again, complete and activate. And again, and this is how simple it is to create a data service. Okay, so you saw both the data service, the PCM, the SES is very, very similar. Just you don't have the need to select the different channels. And it's exactly the same. SES MPLS, point-to-point, select endpoint. In this case, it will be either an E1 or an STM1. Okay, again, selection of endpoints, filling out parameters relevant for E1, complete, activate, and that is it. Of course, we can also create other related stuff over the data services like CFM, and we have monitoring capabilities, 1731, etc. And that is it. This is the service provisioning. You saw how simple it is. Few clicks, and that is it for me. Back to you, Marco, unless there is questions. Okay.
Thank you, Ram.
No problem. Your stage.
My stage. Thank you.
And Marco, just real quick, just a reminder to everybody attending, the bottom right-hand of your screen is the ask a question box. So as we're going through the material, have a question that pops in your head, just type it in there. Or you can click the raise your hand option on the right side as well. That'll give me an alert that you want to speak, and I can simply unmute you, and feel free to ask your question. We're here to help, and we'd love some feedback, so feel free to interject at any point. Thanks.
Okay, guys, I am already drinking my English tea, so let's go back to the business. So now we will talk a few minutes about some specifics in the two selected markets in the critical infrastructure and ecosystem. We'll talk in more details about the power utilities and the transportation, focusing on railway topology. So again, I will close my camera so we can focus on the content. And let's start with power utilities, okay? So in the power utilities, the major changes that are happening can be summarized in the 3 Ds. In the decarbonization D, the transition from non-renewable to renewable sources, solar, aeolic, and renewal and then the rebirth of nuclear power in several countries. The modular nuclear power stations is becoming quite a trend in the Western and Asia Pacific areas. The trend to being capable of storaging energy, so those technologies that are first demonstrated in high, let's say, in high availability and with high availability back 2 to 3 years ago, now they are quite available, and the cost per kilowatt storage energy is becoming lower and lower each day. So those solutions will be part of our reality in the next years. The second D is for the decentralization, and this decentralization has a huge impact on how the OT network will look like, because we will have to connect all those new dots that are producing technology, and those smart meters aggregators, and those new meters to down to the network operational center. So this signifies a quite challenge for the OT operators today, how to reach out and to harmonize the incoming energy from those new sources. And let's not forget that the decentralization also includes the new definition of what we call the prosumer. Okay, the consumer is capable of producing and consuming at the same time, and this trend is likely to increase in the next years. Digitalization, the final D, the implementation of smart systems all over the place, starting from the smart meters in the edge of the network, and smart grid solutions throughout the field area network, distribution, transmission up to the generation sites. And with the introduction of those new systems, we have new platforms and services being introduced in the electricity market. One of them is the WAMS, Wide Area Measurement System, where the PMUs that we just mentioned a few slides ago, they are quite an important element in this puzzle. And one of the key features that the OT network must support in order to provide the benefits from the wide area utilization of PMUs and other management systems is synchronization and timing. So this is critical, so the data coming from those new devices are synchronized and they are analyzed in a proper timeline. So the actions that the operator will have to take upon those measurements, some of them are traditional protection grids, some of them are SIPs, systems integrity protection systems that can protect not a single line, but whole neighborhoods or whole transmission grids or distribution grids simultaneously. So all this is highly impacting how the future OT network will look like. And let's not forget where it all starts. The substation is modernizing. The substation, according to the latest set of standards, the IC 61850, they describes the whole set of new technologies to be introduced, allowing the intelligence, electronic devices, the new generation SCADA, and the IoT and industrial IoT sensors and meters to connect in an intelligence protected and highly available means. And let's not forget, as we spoke before, security and maintenance in this and in any other critical infrastructure sector is highly appreciated. And within this modernization process, proper response for the security and maintenance should be given in parallel all the way along. So then let's take a look at what are the major power sector applications. And we can start, let me see that with the first application that we have been traditionally using our equipment for back from 50 years ago. So we are a major player in the utility one market. So back in the days where we supplied SDH, TDM systems, and now we are providing a migration path to new generation WDM and IP platforms. So this is let's say the most typical space where we will find ribbon equipment being installed, both the Neptune, but also the Apollo. Why I will explain why the Apollo, which is our optical platform, is being increasingly utilized in the utility market. So this is the OT network that provides the connectivity between substations, between generation sites, for the SCADA, for the telemetry, for the CCTV systems, for the operational and administrational voice and data domains. So this is the typical place where you find Ribbon's solutions. The second is the utelco, okay, as you see here, because an increased trend in the utility market, because of many reasons, and we will talk about that, is that several utility companies are becoming utelcos. So one of the drivers for this thing is the 5G. Okay, 5G will require a lot of network capacity, will require fiber all over the places, and the utility companies are quite uniquely positioned to provide at least this infrastructure. In other countries where the gap between the telecommunication services in the metropolitan area and the rural area are huge, like for example the United States and certain European countries, the utilities will also become the platform to gradually decrease this gap between the quality of telecom services in those different environments. So again, the utility companies will adopt a different business model and become a full retail or a carrier of carrier utelco, and they will transport or deliver broadband telecommunication services to both residential and business customers. So here we have focus on the Apollo platform, because the Apollo platform provides this capability of delivering broadband services along large distances with almost unlimited capacities if we take into account the tens of lambdas spectrum available that we can utilize. But also the Neptune is quite important, because once we go down into different business models, for example, 5G backhaul or LTE mobile backhaul, or business and residential services utilizing wireless, fixed wireless services, or copper-based access, we need to go down from the optical layer to the service layer. And the Neptune is the platform that will deliver and switch those layer 2, layer 3 services and provide all the continuity of services for the 5G backhaul. Okay, because 5G backhaul is not a simple thing. It requires a specific set of features where that must be available on the transport layer in order to fully benefit all the different 5G classes of services. And last but not least, as we spoke before, in the distribution layer, okay, in the DSO ecosystems, we are looking at increased penetration and utilization of fiber. So fiber is being extended from selected sites up to the customer premises, and it's being utilized not only to connect the smart grid systems and applications and services, but also to provide the backhaul for delivery of future broadband telecommunication services. And here the Neptune has a different set of platforms, from very small to medium size and very large chassis, to deliver all those services with the required cost benefit and fan out for each site. So those are quite important features. Just a second. Okay. So let's see some examples, okay? So one of the examples that we can talk about is BKW. And sorry that we still have erase, okay. So BKW is one of the examples I would like to share with you. It's a full power company in Switzerland, meaning that they are the generation company, but also transmission and distribution company. They are mainly responsible for the western part of Switzerland, and they have a variety of power plants. Some of them are hydro, some of them are nuclear, and they are increasingly connecting more devices to the electrical grid. And this operator has taken from Ribbon many different layers of solutions. Starting from the Apollo, as you can see, let me show you here. Like as you can see here, the core of the network is a WDM solution based on the Apollo. And this core, a very high capable core, was required because of the large number of data centers they had, they operate. Basically also they have three major locations for BKW, so they have to provide broadband connectivity between those three sites and their data centers. But additional to that, they also are responsible for delivering broadband services using their fiber infrastructure to several governmental agencies for the Switzerland, for the Swiss government. So they utilize the fiber infrastructure and the spare spectrum in the fiber to deliver those secure and high capable services for the different governmental agencies. Back in the down to the substation level, and we have more than 100 sites covered today with the Neptune. We have the Elastic MPLS solution, and I just described it in the past, but I will talk about it again. The Elastic MPLS solution is the capability that we have in the Neptune, in the NPT platform, to support simultaneously both MPLS-TP and IP MPLS. And this was very graphically and straightforwardly described by Ram in the previous sessions. So this dual stack solution was required in one hand to provide the mission critical ensured parameters for the teleprotection, for the PMUs, for the SCADA systems, and the IP MPLS is being utilized to provide continuity of the IT services throughout the OT domain. And this is being managed today by the LightSoft. That is the same platform that Ram showed you in the past minutes, but redundant in three different sites, okay, with the RDR. RDR is for remote data replication. So this is an additional software of the LightSoft that allows the software to be deployed in different sites and to synchronize between the sites to achieve a very high level of availability and security. And they are using the Light Insight as a tool to provide a full visibility of the inventory and to overview the SLA QNS being delivered by this operational network. So about the Light Insight, you will have a presentation very soon in the end of this session today by Yoram. So coming again, other customer, we have Naturgy. Naturgy is known previously as Gas Natural Fenosa. It is a hybrid company based in Spain, but with presence in tens of countries, with serving more than 18 million customers. So the Naturgy, formerly GNF, provides both transport and distribution of gas and electricity, as well as generation of electricity. So they are a full-scale power utility, as we say, and it's one of the leaders in the Western world in the utilization of renewables. So up to last 2 years, they relied heavily on SDH technology, TDM technology, for their several operational networks deployed all over the place. And we have signed with Naturgy a frame contract, so we will be modernizing their network, migrating from SDH to MPLS. In some special cases, we will deliver an hybrid matrix, so we will be able to support native SDH alongside MPLS services. In several ecosystems, we will combine the Neptune platform with the Apollo platform in order to provide more resilience, more bandwidth to reach out longer distances. And one of the key features that was part of our project with Naturgy is the capability to provide a layer 1 encryption for their optical layer. And layer 1 encryption is very important because it's what we call the bulk encryption. It encrypts everything. So basically with layer 1 encryption, nobody will be able to see MAC addresses and IP addresses. So you will have a true multi-layer security in the optical infrastructure. So this layer 1 encryption is very flexible, so you can activate it on the whole bulk of the fiber. You can select alternatively, you can select specific spectrum, specific lambdas, or specific interfaces, user interfaces. Okay, so this is very flexible instrument. Besides that, we have a hardware-based layer 2 and layer 3 encryption schemes supported in the Neptune. So basically, we are providing a multi-layer solution utilizing the Neptune and the Apollo. So let's talk about a few words about rail utilities. So what is happening today is that in the railway market, we are looking at increased introduction of automation systems in Europe, and that's the focus of our presentation today. We have more and more integration with the ERTMS, European Railway Traffic Management systems. Most of the railway companies are increasingly the automation systems utilizing CBTC, communications-based train control systems and technologies in their infrastructure. They are enhancing both safety and security all along the stations and substations. And one of the key reasons for that is to try to increase the frequency and of the trains utilizing the same infrastructure. Alongside of that, they are trying to improve the customer experience while traveling on railways and subways or light rail systems. So they are delivering value-added services for the commuter. They are supporting the smart mobility, so they are providing broadband Wi-Fi coverage in most of their stations, and sometimes on board the trains. They are looking at the different telco business models because as in the power utility, they have a widespread of fiber throughout the different countries, so they can maximize the utilization of this infrastructure for other purposes. And in Europe, at least, most of the lines are migrating from diesel-based systems to electrical lines. And here, the objectives are two. They want to decrease the CO2 signature of the service, as well as increase the speed of the trains in the same way. So this is a trend going on in all major railway systems in Europe. And another bad news is that not only SDH, SONET, and TDM are reaching end of life, but also Tetra and GSMR are reaching, of course, dependent on different vendors, end of life, and will be more and more difficult to support and to maintain in the years to come. So that's one of the drivers for the railway companies to look into the FRMCS, the Future Railway Mobile Communication Systems. And one of the key technologies being tested today by railways is 5G. Okay, LTE-R and 5G, both of them are competing to be deployed in the next years in the railway sector. And because of the capabilities of the 5G alongside, for example, the slicing capacity, the capacity to run different services with different SLAs, with different resources, with allocated resources, different orchestration using the same platform is something that is very interesting for railways. So the 5G is very high on the priority table for those railway companies to be tested, approved, certified on different use cases. And of course, in terms when we talk about smart mobility and value-added services, 5G contributes a lot on that. So 5G has capability to deliver broadband services to any commuter on a train traveling on hundreds of kilometers per hour, 250, 200 kilometers per hour. So it's a true game changing in the utility marketplace. So what are the major applications that we are talking when we talk about the railway? So again, we will start with the most typical places where Ribbon has been present till now, and this is the sidetrack backhaul. Okay, so in the railway market, we have several OT networks. Okay, it's never one network alone for that. So we have one OT network that is a closed network system for the signaling and interlocking. So this is one OT network or one OT layer, and then they have a system OT for the video, for the billing, for the backhaul of Tetra and GSMR, for the dispatching, and they have another OT network focused on the electricity systems deployed alongside the railways. And of course, all the CBTC building blocks are deployed alongside the tracks. So all those systems, devices, and applications must be supported with a very capable, resilient, protected, and flexible backhaul. And this is what we have been deploying in this marketplace for many years. First utilizing SDH, but nowadays all the new projects are using the MPLS-TP technology. And in some other systems with less critical OT deployments, we are using carrier Ethernet and even IP MPLS. Depends on specific requirements on each and every project. But this is the typical place we are present today. The second one is the UTelco, okay? As you see here, quite like before. As we spoke before, the railway companies are quite uniquely positioned to become a UTelco, and we will see examples exactly about that. And their purpose is one, to deliver carrier of carrier services for the traditional, for the incumbent service providers, utilizing extra spectrum available in their fiber or extra fibers in their infrastructure, both business and residential services, and backhaul for the LTE and 5G. And as we spoke before, 5G requires a lot of network capacity as well as fiber all the way along. So those are critical elements where the railway companies will have a very important role in the years to come. And last but not least, every railway is an enterprise. So they have corporate offices, sometimes they have different business units, and all those business units and corporate offices must be connected. So we're talking about typical enterprise broadband connectivity between the sites, and here we're talking about the provisioning of Wi-Fi backhaul for the stations, for the delivery of real-time or near real-time info entertainment services, to connect the different data centers of the company, and to provide at the end of the day the IT and OT backhaul. So let's take a look at some examples in this marketplace. So let me come back to the normal. So one of the examples I would like to share with you is Deutsche Bahn. Deutsche Bahn is a very complex group of companies. So they have the DB system and is responsible for the IT infrastructure and the network infrastructure alongside Deutsche Bahn, but they have other business units within the Deutsche Bahn group. Some of them are responsible for the infrastructure, some of them are responsible for the financial services and the administrativity and the administration services. Some of them are responsible for the maintenance and services to operate this huge infrastructure, and some of them are providing financial support for the growth of the German railway system. And so we are deploying with Deutsche Bahn through DB system. It's a very long-term partnership that we have with them, a very highly resilient and scalable nationwide DWDM network. So we're talking about first deployment of 88 sites. At the end of the process, we will be covering around 900 sites with a very highly capable DWDM network. One of the purposes of this sophisticated optical layer is to deliver the telecommunication services for all business units of Deutsche Bahn, as well as become the platform for Deutsche Bahn U-Telco entrepreneurship that will be available in the next years as part of their corporate evolution and growth. So this is one very interesting reference that we have in Europe. But one of the good about Ribbon is that, as described it by David in the very beginning of the session, is that we are not limited no longer to the optical and the IP portfolio. We have a whole set of voice-oriented solutions, and here is a good example of utilization of session border controllers to provide the network security and segmentation for the voice domain of Deutsche Bahn. Okay, so basically they have all the emergency voice services, their fleet management voice services, their head offices, their call centers. So everything is being segmented and protected by the massive utilization of SBCs on premises and cloud-based for the protection of this huge voice network. So this is a good example where Ribbon is part of several layers in the Deutsche Bahn ecosystem. Another interesting example is RZD in Russia. And it's interesting because of the huge scale of this network. We're talking about one of the largest railway companies in the world in terms of length of tracks. We're talking about 85,000 kilometers of tracks, and of those, only 62,000 is today equipped with automation and remote control system. So we are part of the legacy RZD telecommunications network. We deployed SDH and TDM technology back more than 5 years ago, and we are present in most of the key sites of RZD. And we are now engaged with a very ambitious and long-reaching project to modernize the complete network of RZD with two different layers. So we are providing a countrywide DWDM for both for the SDH and the new coming MPLS-based operational networks, and we are providing CWDM for their operational and IT integrated services. So this, of course, because of the huge distances involved and the complexity of this operator, it's a project that will go for many years, but at the end of the day, we will be looking at a fully modernized network utilizing both MPLS-TP and IP MPLS, delivered over an optical transport layer, covering the entire length of the Russian territory. So this is quite interesting project we have been involved. And just a few summary of what I have just presented. So basically, when we talk about modernization, we talk about two major strategies to modernize a network. One of them we call the IP overlay. The IP overlay is a strategy to modernize the network where if we have and when we have extra fiber available between the sites, we deploy a packet-based network, okay, a packet-based network alongside the SONET SDH existing infrastructure. So the migration of services is done very gradually and very slowly, but very secure. So this is a risk-free migration strategy. And this is a strategy allows the implementation of new IP Ethernet-based services in the packet layer and the migration of the mandatory legacy services using circuit emulation throughout the packet layer in the future. So it's a process that takes many years, but at the end of those 5 up to 7, 8 years, the whole length of services from the legacy SONET SDH network will be migrated to the packet layer. Another strategy that we are using is something that is already shown here in my examples, is what we call the OTN underlay. So it's for those companies with not enough fiber in their infrastructure or with the ambitions and the visibility to become a utelco. So if you are one of the two, so one of the first steps that we advise to do is to upgrade their optical layer, optical transport network. So here the first action is to deploy the Apollo, okay, with a state-of-art DWDM network, and to train the existing SDH network to one of the lambdas available spectrum over this new OTN layer. As it is done, we deploy using another lambda, another spectrum, packet-based network, and again, as in this example before, we slowly migrate and channelize the new services to the new packet network. So basically, all those strategies are providing a risk-free modernization. So this is one of our top pillars in our strategy and go-to-market for the critical infrastructure market. And then we provide security. Security is very important, and as the networks modernize, cybersecurity solutions must be placed in order to ensure that this new network is fully secured. And there are several cybersecurity functionalities and appliances that must be utilized. There is no one solution fits for all. So this is a quite complex solution, and we have the expertise on that type of work. And then to provide as much as possible a customized end-to-end solution to improve their management capabilities, because one of the key elements to increase the security levels of any network is to reach out and to being capable of visualize all the different network assets in the network to deliver the required elasticity in terms of user interfaces, network protocols, the Elastic MPLS, the combination of legacy, serial, and new generation Ethernet-based interfaces, and the capability to support this solution for at least the next 10 years that are coming. And this, because this is the minimum lifespan expected in any critical infrastructure project. And we have to talk also about convergence of IT/OT. This is something that is happening. The level of convergence is something that is different from case to case, but we have what it takes to provide a fully converged and secure IT/OT environment. So we are starting with the traditional optical solutions that we have, with traditional optical slicing, which are considered by all the cybersecurity agencies as highly secure to provide transport of different services with a high level of security and segregation between them. We are delivering the next generation slicing technologies with an Neptune. Those are technologies that were developed for the 5G deployment, and those are available for any OT and IT converged data network. So this is another layer of convergence that we can provide, and of course we can manage all that as easily and as simply as it was already shown by Ram, and it will be shown in the next session as well. And if it's not enough, we have all the cloud and edge portfolio with the voice domain solutions for the session border controllers, the analytics, the security, the on-premises, cloud-based systems provided, so we can integrate it, what we call the unified communications in the IT and the OT domain altogether. And let's not forget 5G. One of the most important features that we have to look into the equipment is their readiness for 5G, because if we have a very long-term strategic vision of where our OT and IT network will bring our company, we have to consider 5G in those use cases. And it has already been deployed and proved the importance of 5G for the industry, for the residential market, for the enterprise market, and for the mobility. Okay, all the railway, expressways, all the autonomous and electrical vehicles upcoming, all the capabilities to connect AIs and IoT throughout all the geographical reaches. So those are very important elements that we have to look into the supplier to see if their equipment supports those 5G related functionalities. And we have a complete portfolio for that. Okay, we have what it takes for the broadband core, for the utility wide area network, for the field area network, and several software solutions for the complete end-to-end management of the layer 1, 2, or 3 transport layer. Okay, the Muse orchestration that utilizes SDN capabilities and technologies that can provide a comprehensive fiber health management for the optical layer infrastructure, the analytics and reports that you see very soon in the demo, and the advanced capabilities of the NMS that will be shown again in a few minutes by Ram. And we have a lot of customers. We have been present in the critical infrastructure market for more than 52 years. So we have about 250 different customers. And in Europe, 6 out of the 10 largest electricity companies are customers of Reborn, and starting from ECI in the past. And then in terms of railways, we are even similarly positioned. We have almost 40 to 50% of the railway market utilizing Reborn legacy and new generation solutions. And then the reasons for that are very simple. We have the platform ready for 5G. We can aggregate all those multi-service platforms into one platform. We support the mission-critical IT and OT solutions, and we have high-capability optical solutions combined under the same management. So this is very important. And this is what we have to take to lead you in this marketplace, complies to the different standards, to become a 5G player. So whatever you would like to deploy 5G related functionalities in the OT or IT domain, we are able to support those. A very flexible set of network protocols in terms of transport for the layer 2 and layer 3 services, We have the MPLS-TP and the IP MPLS with RSVP or not that can operate simultaneously over the same platform, and almost unreliable scalability in terms of network platforms and the number of ports. So we have what it takes to be a partner of you in our modernization process. So with that, I return the word to Ram that we will further demonstrate our capabilities as we just talked about them.
Thank you, Marco. Tell me when you see my screen.
Yes, it's on the screen.
Thank you. Okay. So continue from here, I will show you a little bit about our IP MPLS capabilities, how it is handled in the NMS, about the different quality of service streams, and how we can make sure that all the OT services and the IT services are not causing any congestion to each other. And we'll finish with a small demonstration about the MACsec card that we have. So when we talked about the Layer 3 VPNs, if you remember, only this small checkbox actually decides if we want to use MPLS-TP tunnels or not MPLS-TP tunnels. And if you remember, the dotted line means that we are going to use dynamic tunnels. And this is it, actually, from the services point of view. It will be a very small demonstration because we already talked about the services. And if we are talking about services over IP MPLS, everything is exactly the same. You don't need to learn anything new. The only thing you need to know and remember is not to check this box, and that is it. Okay, so this is the only difference, and I want to give you a short glimpse of the protocols that we have in the Neptune device. Just open it up. Okay, so if we go to the configuration part, you see here we have the protocol stars, and we have all the different protocols you would expect in an IP MPLS network. For tunneling, we can use either LDP, segment routing. Next version will have RSVPTE. And this is if you are familiar with IP MPLS, it's a one-time configuration, and that is it. And then everything you configure on top of it from the Lightsoft, you just said you want to use a dynamic tunnel, and that is it. Okay, it's a one-time configuration for the protocols, and then from the Lightsoft, the management system, the provisioning is exactly the same as we showed for the MPLS-TP. This is how simple it is. In addition to that, you have also the support of Layer 3 VPNs. Okay, if you will need for your IT network to create a different Layer 3 VPNs, or in addition, if you're going to become a utelco and you're going to create Layer 3 VPNs, I don't know, and to sell business services, etc. So also from the same Lightsoft system, we have the option to create a Layer 3 VPN. And it's very, very simple, very similar to the Layer 2 VPNs, but of course the Layer 2 VPNs has different parameters, but the provisioning process is somewhat similar. Okay, again, I'm selecting where I want to have, in this case, what we call a VRF, and Layer 3 VPN is composed from VRFs, virtual routing forwarding, in conjunction to Layer 2 VPN, where we create what we call the VSI, a virtual switching instance. Okay, so we add a VRF here, we add another VRF here. For each VRF, the basic parameters of Layer 3 VPN, I don't know if you're familiar with that, but it's like route targets, route distinguishers, adding the relevant interfaces here. And you can, from the NMS, create what we call a LIF, a logical interface. You don't need to do anything on the device itself. And that is it. Again, complete, activate, and you have a Layer 3 VPN running on your network from the same management system. And again, same device, same ports, nothing new to be added, no new learning curve for a new management system, etc. Regarding the quality of service, MPLS-TP is working with a different quality of service scheme. If you remember, when we created the tunnels, I needed to select the different classes of service and bandwidth for each tunnel. That means for each tunnel, it's like has its own network queues for the traffic. Okay, IP-MPLS is working with a different scheme. It's called the diffserv scheme, where we configure the different quality of service parameters per port. Okay, and all the different dynamic tunnels that go through this port are acting according to the specific configuration of the different parameters. Again, committed interface rates, excessive interface rates, of course, according to the specific customer QoS scheme. So how do we differentiate between them and how the NMS manage it? Okay. So first of all, in order to configure the diffserv scheme is very simple. It's per port. You do it, by the way, this window I'm opening all the time. This is the EMS, the element management system, where we configure all the different physical stuff like ports, assigning cards, protocols, etc. And if I will go, for example, to a port, and I will show you. You see here, it's called the diffserv block, and it's exactly the same as we did for the tunnel. We have the different classes of service from 0 to 7. Of course, we are supporting all the different classification methods, if it's by PBit, if it's by DSCP, if it's in the MPLS side, we support EXP. So we support all these different classification and marking capabilities. And again, here, I'm deciding what the amount of committed rate and excessive rate I'm allocating for the diffserv scheme that is used for the IP-MPLS part. And of course, the tunnels that we created, we are creating the bandwidth that are related to the TP and the OT network. How do we see it in the NMS? If I will go here, I will just do a properties here. Okay. We have what we call CAC. Okay. CAC is, of course, I forgot the acronyms, never mind. You can see that I have an allocation of bandwidth per scheme. Reserve bandwidth, that means that it is reserved for the MPLS TP part, and diffserv bandwidth, this means that it is reserved for the IP-MPLS. Okay, these parameters are taken from the element, the configuration I showed you before, and this is configuration I'm creating in the NMS in order to tell the NMS how much bandwidth from the port I want to reserve for the different classes of service, but for MPLS TP. Okay, in this example, half of the port I'm allocating for the MPLS TP, and the rest could be for diffserv. In this case, just for the example I configured for class of service 5, the 2,200 megabytes, 2.2 giga. It's 22%. You see the total is not reaching 100%, so I have more to play with. And I can do it in per port, per class of service, but the NMS will help us not to oversubscribe the port. Okay, if you will try to create an MPLS tunnel that will cause to oversubscription, and oversubscription means that we will have probably congestion in sometimes, and we don't want that. By the way, for congestion, we have the different methodologies that to handle congestions like WRED, etc. But the NMS will help us taking care that we will not actually oversubscribe. We do have the option to say to the NMS that we are allowed to oversubscribe, and CAC is just remember that it's connection admission control. Thank you, Johan. And with this is how we can control the different allocation of the bandwidth in the NMS. This is the CAC configuration. And if we want, we can also see the availability, and it will tell me exactly how much I'm actually provisioning. Okay, the other window is the configuration, how much I want to reserve for each. And this is if I want to check the current situation that I have on the links to see if I have more room to create more tunnels and not, wait for the warnings and the the NMS to tell me that I cannot do that. I can always monitor it and see how much I have left on the links. So this is regarding the QoS and the CAC in the NMS and how it helps us to operate the network and manage the bandwidth allocation. The last thing I want to show you is the MACsec. I showed you the card, the ports, just a small window here, MACsec, and here I just configuring the different things related to MACsec, like the cipher. We can do 128 or 256. We can change the CAK. We can refresh the SAK. If we are, it depends if you want to do static or dynamic key exchanges, and everything you can do from the NMS. And it's very, very simple, very, very few configurations, and you have encrypted links with MACsec over your network for your traffic. That is it for me. If there is no questions, back to Yoram, I guess. He's the next presenter.
Yes.
Okay, so thank you very much for the attention.
So whilst Yoram was waiting to come up, I did get one question in on the chat box. I don't know, I guess it's Marco, but I don't know if there's anything you can do as well, show Ram, is if you've got you're trying to introduce our solution into a newly into a competitor, I'll try that again. I'm just reading this question. Basically, how do you introduce a ribbon solution into a legacy network? And what experience have we got at that, and how have we managed to do it? So Deutsche Bahn was a great example of that. What was our experience about how we introduced, the ribbon solution as a new solution in that type of environment?
I will let Marco answer.
Okay, so one of the slides that we showed was demonstrating the different strategies that we have to modernize the mission critical network. And basically we described two different strategies. So the smart way to introduce a new technology into the network is to make it run in parallel to the old one. And this is one of the first steps to make this new network available. Then to freeze the whatever services and new services introduction in the previous SDH TDM network, and gradually introduce the new services, and in some cases they migrate legacy services over the packet, new packet layer or new packet network very gradually and in a very slow process. And those are the winning strategies that we can recommend to be utilized. And as we spoke before, they are completely risk-free because no mission critical services is compromised doing in such a way that we just described. So I hope that it answers the question. Okay, Yoram, take us ahead with the lighting side, please.
Thank you very much. So nice to meet you all. I hope you can see my screen.
Yes, we can.
Yes.
Very good. Thank you. So this is going to be the last live demo for today, and I will show you guys the lighting site, as you can see at the top left at the heading. Light Insight is a network analytics tool. Ram showed previously 2 sessions regarding Light Insight, which is used for day-to-day provisioning management.
Lightsoft.
Yes, and the Lightsoft, sorry, and the Light Insight is used for network analytics. This tool comes to complete the management suite, okay? And it provides, what it does, it collects information from the Lightsoft, okay, and from the EMSs that Lightsoft manage. And as a result, it provides the user reports. User use those reports in order to better improve their networks, to identify bottlenecks, to provide reports for services, for inventory, and also to provide reports for SLA for monthly basis for the end customers. A few highlights regarding this network analytics. This tool is not a real-time tool. It collects the data out of the Lightsoft and the EMSs once a day. If you take a look on the right side here at the top, you will see the last time the data was collected. So the data is collected once a day, in every day. So it's not a real time. The second thing that you need to know regarding this tool, that it has predefined reports, as you see in front of you. Those are the reports that were most common and were defined by our marketing. In addition to this, I will show you at the end another way to define reports, which are the customized reports. And we'll see it in the end. So we have the predefined reports, we have the customized reports, and another thing that you need to consider is regarding the SLA or the performance monitoring. Since we'll use here reports in a few minutes that I will show you to show the services SLA, those reports are based on counters, and those counters are available only when you enable the performance monitoring via the EMSs. So prerequisite for the services SLA is to enable the PM. For the inventory, you don't have to enable the PM. Okay, so this was some startup highlights for the application, and let me show you further information. What we see in front of us, we see the dashboard of the Light Insight. Okay, let me close the video so you can better focus. We see the Light Insight is divided to multiple tabs. Okay, we call it dashboard. Each tab focus on a different specific technology. What we see currently is the physical network inventory. Okay, and then we have additional technology for the packet, as Ram showed you, for the inventory of the cards, ports, and services. And we have the packet network performance that will show the services and the SLA. We also cover the SDH if you have Silkut services. And also we have the DWDM layer, which is the OTN network inventory and performance. And the last tab is the system health, which can show us information regarding the alerts. So let's start from the physical network inventory, and let's take a look on important information that we can gather out of this network analytics. Here we have widgets, as you can see. The dashboard is divided to multiple widgets. In the top left, we have the widget that shows us the network elements distribution by product line. We have a pie chart, okay? Within this pie chart, we can see the distribution of the number of network elements according the platform, the product line. Okay, and it's important in order for the designers, for the operation department to know exactly the inventory and the equipment that they have. Each widget that you show in front of you is right-clickable. Double-click on the widget itself will get us through to the table inside in order to have further information for the widgets. And what we see in front of us, we see the same widget that we saw before, only this time we have additional information of this pie chart presented in a tabular view. Okay, we have the product lines under which EMS it is managed, and what are the quantity of network element that exists. Okay, if you want to have a drill down view regarding the type of models that we have, we'll go to the bottom. Here we have a focus on specific product line that we can select. We select the NPT, which stands for Native Packet Transport. Okay. And what we see a pie chart with the different types of models that we have in the networks. The same information is located on the right side in the tabular view. And this is a good example to show that we have also columns for the IP address of the network element, the time it was installed, and the software version of each network element. The software version allows us also to have a report in order to verify that all the network elements software version are synchronized. If not, we can plan an upgrade accordingly. Each report can be exported to each type of from the format files that you see below. An Excel or CSV is the preferred in order to have a further analysis of the reports. Let's click on the return button here. And we'll go back to the dashboard. If we go to additional important dashboard in this physical network inventory, we'll see information regarding the slot utilization by product line. What it gives us a useful information how occupied is our chassis in the system. And we have here a color code for each one of the platforms, the Apollo, the WDM, the NPT, okay, for the packet. For each one of the platform, we have the color code that indicates how much it is, how many network elements have slot utilization. For example, higher than 80%, we can see it here. Okay, we see 6 network elements of NPT. Lower, we have 7 NPT, and etc. And the same concept that I explained before is if you'd like further information, double click on it. Double click on the widget, and you will have further information. So the same information regarding the slots utilization we'll have on the right side in the tabular view. Okay, as you can see, we have the slot utilization. You can sort it. We have 100%, for example, because all the slots, we don't have any available slots that we can insert a new card. But if you can go below, you can see other network elements which has available slots. Okay. You can see also the network element type and the name. Let's click on the return. Now, every single and each report that we showed here can be exported as well. We talked about the slots utilization. Let's take a look on the port. It can be cases where your chassis are almost empty and they have very few cards. However, the cards includes ports and all the ports can be fully populated. So you don't have any additional ports in order to install or to plug a new service. And this information can be viewed here in the port utilization. So here we have a view. What is the port utilization? Again, same color code. We have the high, the purple, and the low here, 20%. You can see the quantity of network elements. For example, we have 25 network elements whose ports in the NPT are lower than 20%. Again, I'm not going to drill down the same concept. If you don't have any specific question for this physical network inventory, I will switch to the packet network inventory, okay? Okay, the packet network inventory provides you information for inventory, but focus on the packet, on the data layer. It pulls the information from the Lightsoft and the EMS and it shows what you see in front of you. Here we have a pie chart widget that shows us the services by the service type. How many services are from the type of point-to-point, from the layer 3 PN, circuit emulation, so on and so forth. Again, double click will enter to the table view as well, which you can further filter and export the reports. Here in the right widget, you can see the services that we have in the lighting side according to the service state of Lightsoft. It means that if you have any problem with the service state, it can be unknown service, it can be incomplete, it can be inconsistent state, you will see it here. And then you can further investigate and take it with customer support to resolve the issues. Ram talked about the SRLG. SRLG stands for the Shared Risk Link Group. And in case you have protection of services that both main and protection path are passing via the same fiber duct, you will get a notification here. Currently, I don't have in the system this kind of issues, but this is very important because once there is a fiber cut, you will have a traffic affecting because both the main and the protection are passing via the same fiber duct. If you go to the bottom, we'll see information on the MPLS tunnel that Ram showed before, and here you have the inventory for the tunnels. If there are any tunnels which are provisioned as unprotected, as we see in the system we have. In this case, if there will be fiber cut, the service will be down. So in this case, the customer need to do his best if there is a physical or logical path in order to edit those tunnels to become protected MPLS tunnels. Also on the right side, we have inventory of unused tunnels, which means those tunnels were detected in the system and that are not carrying any service. In this case, user can delete them. If they're created for future need, he will leave them in place. A very important tab, I will switch to additional environment here, is the packet network performance. Again, we are now in the packet domain, in the data MPLS domain, and one of the important reports that the customer need to provide to his end customer is the SLA, and also he needs to monitor his capacity and bandwidth of the network. So what we see in front of us, we see from left to the right, we see a widget that shows us the network ports bandwidth utilization. It means that we have the bandwidth capacity. Those are the ports toward the MPLS, and we have information regarding the utilization and the rate, megabit per second. And in this case, if the customer monitors the ports and he sees that the capacity or the bandwidth exceeds a certain threshold, it's very important for the designer department to take it into consideration. They might consider to increase the port rate or add additional link and so on. Same concept goes for the user port. Those ports are connected to the end equipment, like the routers, okay, for instance. So we have the information as well. A double click on it will provide you full details with a table. But I would like, with your permission, to concentrate on the service level. Once user configures services, okay, in the system like Ram did previously, we have the list of here of the top 5 services with highest throughput. You see the number of services, their ID with Lightsoft, and we have the total received throughput that we have in the system. Okay, if we double click on this to open the service list throughput report, we'll have a list of all the services in Lightsoft, and the selected services here will reflect the information of the graph below. The graph below shows us a throughput, daily throughput, okay, from the time we open the PM, okay. We have here information regarding the transmit and receive throughput. This is a highlight view. And if you want a detail for every endpoint, you will double click on it. And what you will get is information of the receive throughput and the transmit throughput for every endpoint here. Let's wait for a few seconds more. Here. So here, let me select only the class of service 0 in order not to over populate the screen. And this is what we have. We have utilization over the time for only specific service that we're interested in. And in the bottom, you have the daily information for all the counters of the receive, throughput, and transmit. So we have this availability. Okay. Further than that, I would like to show you the SLA for the services. The SLA are determined by the service CFMPM with the standard of Y1731. And here we have indication for the services in terms of availability and delay measurement. Here, for example, we have a note how many services suffers from downtime. If we double click on it, we'll get a list, concentrated list of all the 3 services that have a downtime during the last 14 days. This interval can be changed. If I click on the return, I would like to take you further than that to open the CFM-PM report and to select a specific service for monitoring. Okay, this is the service that we are interested in, and we want to provide the customer the key KPIs for the SLA. So what we see the daily information, and we see the information regarding the average delay, maximum delay, jitter, how many frames exceeds the delay, how many not. As you can see, in none of the dates this specific service suffers from any jitter or delay. If you go to the bottom, so this is the delay measurement, which is important for the customer because some critical infrastructure services, they must meet a specific delay. So in this case, the CFM-PM provides you a way to measure what is the delay for the service before the customer connected his end equipment, like teleprotection. If you go to the bottom part, we can see the availability measurement that shows you how much time the service was down or not. So all in all, it provides you a report for the SLA that you can generate monthly for your customers. I'll click on the return. Also, in the same concept, we have information regarding the SDH network inventory, very similar to the previous one. Okay. OTN network inventory. Oh, sorry, regarding this. This is the SDH network inventory. I'm working with multiple environments. SDH network inventory shows you information regarding the trails that you have in the systems. If you have unprotected trails, you will see it here. What is the type of the services? What is the protection quality? If it is fully protected or partially. And according to this information, you can better improve your services and protection types and utilization of the network. Marco mentioned also the DWDM part. So the Light Insight also provides information regarding the OTN. You can see the information regarding the utilization as well. OCH, this is the DWDM lambda. It means if you can better utilize it, you'll see it here. How much channels are occupied out of the OTN, how much are free, you will see it in the OMS section. Okay. And also regarding the OTN network performance, you'll have the ability here to gather information regarding the performance of your services in the DWDM. As you can see here, we have the services of the trails that we have. We can see the bandwidth utilization based on our counters. And we have also information in the DWDM regarding the optical parameters. It's very important that we'll have that you will monitor your transceiver receive power and transmit power in order to detect if there are any issues that concerning a degradation in fiber input or transceiver. Okay. This is regarding the OTN performance. System health showed you general information regarding the alerts. We have a pie chart regarding the alert distribution. Okay. We have information regarding different type of alerts for the physical layer, for the fans, for the power supply and temperature alerts. Okay. And last but not least, I would like to show you a simple example how to create your own reports. Let's say that you would like to have a customer's reports. You'll do it in a following way. You click to the analysis, and by the way, this infrastructure is based on Oracle BI. Okay. So what we're showing you now, we're showing you some sort of under the hood how to create a report. Let's say we're interested in the NMS name, IP address, and the version. And let's say they would like also to get the EMS name and the IP address. And we'd like also a report for the network element name, IP address, and the version. Very simple. You click the parameters from the list. Once you have the parameters for the query, you click results. And all the information is presented here. From the list here, you have full flexibility to create any report that you think you can save the report. And after that, what you can do, you can create an agent that will send the report to your email every interval, let's say for every month. So it's very convenient. You can also create filters. Let's say that if there's a throughput that exceeds a certain threshold, it will filter the information. A very powerful tool. This is the end of my demo. If you have any question, please feel free.
Thank you, Yoram. Basically, we reached to the Q&A session. This is the end of our presentation today. That's what we had prepared for you today. So if you have any questions, doubts, let us know.
I can see a couple of questions, Marco, on the question box. The first one, I guess, is for you. A number of vendors are touting or recommending IP MPLS for all services. What are our thoughts about this?
Well, we are quite holistic, as since we support both stacks in our product, both MPLS-TP and IP MPLS, and we are adding to the next versions the full traffic engineering stack to the IP MPLS. So basically, we are quite holistic. Professionally speaking and technically speaking, we still would prefer to have MPLS-TP for all the mission critical systems and applications, because it's quite similar to what we are used operating the legacy SDH and TDM and SONET platforms today. So not only the operation is similar, the results, of course, are equal or at least very similar. And but since we support both stacks, we are open to any network topology, and whatever the customer feels more comfortable utilizing, we will go through.
Okay, that makes sense. I hope that answered the question. Of course, we can always get feedback if it did not. The second one I've got here is you mentioned some more disruptive type technologies. How quickly, if at all, are you actually seeing or Ribbon seeing their customers trialing or deploying these more disruptive technologies, things like 5G, cloud computing, advanced routing and transport technologies, etc. I mean, there's lots of slideware and stuff around from us and others, I guess. So this is me adding to the question. But are we actually seeing customers starting to really look at it in a bit more detail and trialing what's out there?
Well, okay, good question. When we talk about virtualization, this technology is becoming available by vendors in the traditional SCADA environment. Companies like Schneider, Siemens, CBB, SCL, they are already implementing HMIs, which are completely capable of being virtualized on standard servers. And this means that they are no longer let's say, locked to a specific vendor when it's about server or centralized resources. Where about cloud, we have two types of possible cloud implementations. In the IT domain, of course, the typical cloud services are already there. In the voice domain, in the typical Microsoft domain, but in the OT environment, most of the cloud systems are implemented in a private cloud, segregated cloud topology. So those different applications and services are physically located within the protected and segmented domain of the operational network. So and they are becoming more and more relevant because that's the way the developers are looking at the future. And it also provides the utility company lots of benefits, avoiding vendor locking on in the technologies, with more flexibility for the deployment and operation, with a lower operational cost. It's a different model between the CapEx and OpEx. And so that's why we will see more and more virtualization and cloud-based systems being introduced in the critical infrastructure market as well. And as they are introduced, network resources and capabilities, we also have to follow on this trend. And we are looking at that very carefully. And regarding 5G and mobile edge computing and edge computing in particular, they will also find a place in this environment. For example, in smart cities, all the next generation traffic control, autonomous vehicles, supervision, and monitoring are based on IoT devices and smart technology. And most of this technology is becoming virtualized on mobile edge, on Mac platforms, distributed alongside the municipality geography. So those are examples of different mission critical and critical infrastructure systems that we are utilizing quite advanced new generation networks today.
Okay, I've got another question on the IP MPLS, MPLS TP type area, or more specifically IP MPLS area, is how would you introduce or coexist or integrate our IP MPLS solution and MPLS TP solution for that matter with an existing IP MPLS network? So the network's already out there, they've got IP MPLS in their network, and we're introducing our solution, both, I guess, the IP MPLS and the MPLS TP variants. How do we interwork and coexist with that?
Well, basically, in terms of IP MPLS, the interworking is quite simple because there is no separation between the control and data plane. The interoperability capabilities that we have in terms of IP MPLS are quite unlimited. It's very standardized technology, so it can be deployed in a multi-vendor environment. Regarding MPLS-TP, because of the different standardization process that it was taking into this relatively newer technology, we have two different flavors of MPLS-TP. One is the IETF and other ITU. So most of the applications of the networks are deployed in segmented or separated domains, where the interop between those is provided by Ethernet or VLAN handshaking, but not on the MPLS-TP layer. And this is what our experience have thought so far. There are a number of vendors that we are working with them to provide a higher level MPLS-TP interoperability, like, for example, General Electric, that we have a global partnership with them. So we will see more and more of those interop and interworking networks operating as the time evolves, and as MPLS-TP or IP-MPLS are widely deployed in the critical infrastructure market. So it's an evolving and dynamic situation we are living in.
Okay, I've got another question, and this is completely the other end of the spectrum. We're about the optical domain. I think we might have touched on it on the Deutschbahn slide. I'm not sure. Is there anything, or what do we do? Can we talk about what we did to do the fiber health management, or making sure the fibers are in good condition? But more than that, can that interwork if there's a legacy fiber network or a legacy optical network out there, and we're plugging ours around that, can we interwork in that environment? So similar question to the IP-MPLS one, but at the optical layer. Okay,
so we have two ways of dealing with these brownfield applications. One is the capability of trailing existing lambdas throughout our managed Apollo-based OTN, which is, of course, fully possible. And then we can also manage the spectrum very flexibly, very effectively through the lights off in those cases. And the other is to transmit our own spectrum using other network operator or other technology provider that is also supported. So both scenarios are quite clearly supported. Of course, there are some limitations. For example, when we talked about secured services over an alien lambda, for example, to run a layer 1 encryption over an alien lambda, this is something that can be done, but demands integration done at the protocol level between the vendors. So this is not so simple to do. But all other brownfield topologies, either we running over other infrastructure or other running over our infrastructure, those are fully supported. And besides that, Ribbon is strongly working on disaggregated solutions that will allow all those types of interworking and interoperability in a much more easier way in the future. So the answer is yes, we can work on a brownfield environment from different perspectives, yes.
Okay, I think that's...
but I forgot something about light pulse. So light pulse is it's a capability that we have developed for the Apollo OTN portfolio that one relies on specific set of OTDR compliant cards that we have to install in the equipment, But once they are installed, they provide us with an unrivaled capability to monitor and supervise the quality of the optical infrastructure end-to-end, meaning the OSNR, OTDR, the power, the fact that the failures or cuts in the fiber in a matter of meters. So the light pulse, which is also called the optical health and management module that we have in our management system, is a very useful tool to provide an end-to-end increased visibility of the optical layer that we have. And this also contributes to the security and also to the smooth operation of the optical layer in an environment. Okay, but it requires specific hardware to be deployed within our Apollo platforms.
Yeah, one thing I would add to that, Marco, on the light pulse side is everybody who we've had deploy it has been very positive. I'm very surprised about how accurate the information is and how useful and relevant it is. And you know, even when it's stuff not really anything to do with us, you know, old fiber in the network and talking about what capabilities of that, where fiber cuts have occurred by malicious damage, etc. It's really like to pinpoint quickly where failures have occurred and do some sort of switch over if that's possible. But if not, do the reactive maintenance and do that without having to go with a handheld OTDR into the network, because it's there all the time, so you're getting real-time information. So, and on that fiber degradation side, the other thing that will surprise a couple of the people we've deployed it into was its ability to watch the degradation in the fiber over time, so they know what state the fiber is and do preemptive maintenance. So that's quite an interesting little bit of a capability if you want to talk further about that. And I think that's the last question we have. So if anybody else wants any questions, quickly type them in or raise your hand with the yellow hand. I can understand why you might not want to do that. Other than that, I'll give it a couple of minutes and then we'll give you a quarter of an hour back. And we must say thank you ever so much for spending your time to be with us today. It's we'd much rather now be taking you out for a cup of coffee or more, but we can't do that at home, so it's a great shame. Maybe next time we can come and do this with you in person, and we can have some very interesting discussions with that. So yeah, I've not seen any more questions come in, so as they do it, going, I need a gavel now, going, gone.